Today's topic is digital engineering and how to make it a smarter driver for collaboration and better decisions rather than complexity. And here is the agenda that we're going to cover today. We will have Philipp covering interdisciplinary model-based engineering as a practical capability. Then Mendel will take over with rethinking PLM, turning today's challenges into tomorrow's advantages. And Sean will close with the integration of PLM systems with SnapLogic. And as mentioned before, we will close off with a Q&A. On the right-hand side, next to the docs and the chat tab, you can see the Q&A tab. So feel free to drop your questions in the Q&A tab anytime during the webinar, and we will try to make sure to cover them at the end. And with this being said, I'm happy to hand over to Philipp's part. And here, a special thing is that his presentation is going to be a bit more dynamic and you will need to follow his screen. So this is why we will stop sharing our screen and we will all go off camera so that you can see his screen a bit better.
Okay, Sinem, thank you very much, and a very warm welcome from my side here as well, from the Digital Lifecycle Lab here in Graz. And I want to start with a little question. So how many of you have the feeling that it is expected that projects are nowadays executed faster and faster, while also the complexity and rises, and it's getting harder and harder to manage these projects? If you're one of those, you're definitely not alone. This is one of the hot topics nowadays we talk with our clients, and therefore our title today is Faster Chaos or Smarter Engineering. And today the three companies, so Antemia, ECS, and SnapLogic, we want to present to you an overarching framework how you can approach and try not to end up with faster chaos, but with smarter engineering. And therefore, we are starting here in the Digital Lifecycle Lab with model-based engineering. So models are the basis and the fundamental part of building up good development data. And if you have this data, you then can implement a PLM system where this data is managed and accessed throughout the product lifecycle. And then also you have some integration challenges, which you can, for example, tackle with the platform like the integrated platform as a service from SnapLogic, where you can solve these integration topics within the engineering domain or even across with your enterprise systems. So having started with this, and I also mentioned one of the top challenges is nowadays this faster time to market. So companies have huge pressure here to bring their products as fast to the market as possible to stay relevant. We have, of course, interdisciplinary collaboration. So there are those traditional silos which definitely need to be broken up for mechatronic product development. Product liability, so how you have developed your product in case of some difficulties later on. So if they are developed on a well-model-based basis, you have your documentation right away and can argue how you develop your products. And of course, complexity, and then the huge topic of data and how you're gonna work with the data and use it later on. And companies nowadays often try to cope with these challenges by digitalization and initiatives in engineering. And very often those initiatives do not bring the desired outcome, and that has manifold reasons. And for example, one of the things we see more often, there are just some tools which are being purchased without thinking it through in detail. So they're then widely connected within the whole IT framework. It isn't really planned what to do with the data that is coming out. And a big topic, the people who should work with these tools are not involved. And then our biggest part here in the product lifecycle, Digital Lifecycle Lab, is that they ignore the processes and the methods for which the tool is only a supporting mechanism. And therefore, we suggest an approach that you need to know where you want to go and why. And this on a very strategic level, but then also breaking it down on an operational level. And therefore, you first of all need to see what is even possible nowadays. So what are systems that are working, and then evaluating these systems and see effort versus benefit. So what makes sense for my organization? We do not need to over-engineer So we only need to implement systems and approaches that benefit us in the end. And when you have defined that, you need to define the best path forward and how you're going to implement all of these systems. And therefore, here in the Digital Lifecycle Lab, we have a very broad and overall engineering framework and platform where we can develop all those models in the different engineering disciplines. For example, here we have our mechanical working station, we have our electronic station, for example, where we build up our PCB models. We have over here our software and our simulation workstation. And this is not just a showroom, it's a hand-on working laboratory where real products and systems are developed. And we can do it in a greenfield kind of setting, but also test some brownfields and see how the interconnection of these tools is working. And here, kind of in the middle, we sometimes say it's our systems engineering point of view or station, but this is not true because systems engineering should be implemented within all of your doing, within all your disciplines, and you should manage your collaboration through systems engineering and through system architecture models, as you can see them here. So whenever you then decide to start such an initiative, you need a certain method or maybe even a tool to approach this initiative. And we always suggest the PathMaker method and also tool, which is a real-time collaboration tool which you can use with all your stakeholders in the company. And you need to define certain steps before you even start thinking about buying a certain tool or something. So you need to set your vision, your high-level vision, where you want to go. You have to assess your current situation. If your current situation is not assessed, you cannot say if anything got better later on. A very key point is addressing all the relevant stakeholders if you want to implement it later on and to not have too many people who are against it. And defining a path, some responsibility, and then also you need a timing and a cost strategy and some risks before you start these initiatives. And when you're starting an initiative, here we have all the working streams from over there collected. You can start your initiative in one area, like the simulation area, for example. And even within one area, you have many collaboration tasks, but these, of course, are getting more complex and more dynamic if you add, for example, systems engineering, electrical engineering, mechanical engineering, and so on. And for that, it's very important to have a clear idea what you want to do and how you want to collaborate. And therefore, Memodia is perfect because in Memodia, you're defining the methods you want to execute in your process, for example. You can then define all the steps this method needs to execute. You have to align the method to a certain process. You can attach the tools which this method is executed in. And then, this is the core, you always have to define the input which goes into the method and the output model which is defined. Because the only reason why we are applying a certain method is because we want the output information. And in this case, our output model would be a requirements model. And in Memodia, you can then jump right into this model, for example. You can have a look at the requirements here in this case. You can go through the requirements models and stuff like that and add something or just do what you meant to do with it. Okay, and then this requirements model, it needs to be clearly defined where this output information is going and where it is used as an input again. So for example, here, if we go to the advanced Arcadia system modeling method, you can see that the requirements model is an input. We have another input from the customer use case. We have it aligned to a process again and to have certain tools where it is executed in. And then as an output, we have here, for example, the system architecture model. And again, we can jump then right into this model we just have to sign in. And then we are, for example, in one of our PLM systems where we see our logical architecture, and we can then work on it or just get some information out of it, which is relevant for some discipline engineers, for example. And since we're here right in our PLM system, I think that's a perfect point to give over to our PLM expert from ECS, Mendel.
Yes, thank you, Philipp. So I will talk a little bit more about PLM, how PLM has evolved, what a modern PLM solution is, and how we can achieve such a PLM solution. So I want to start with a very short history of PLM, because it's always good to know if we head to something new, to understand where we come from, what has changed over the years. So PLM comes from a very CAD-centric world. In the product development process, that means our origin typically is the engineering process. Thus, the handling of CAD data and documents alongside the engineering process typically is the first step into the PLM domain. Because storing engineering results as CAD data instead of CAD files dramatically improved their reusability and the general performance of engineers, it is only logical that we would want to try to scale these benefits to more and more areas of the product development process, or even to other product-related processes, since the insight that a break in the tool chain leads to breaks in efficient and effective processes grew very quickly. So eventually, people became aware that all product and lifecycle information needs to be managed and archived digitally, and that the PLM solution could be the perfect backbone for that task. This became even more and more true since the product development process, alongside all other product processes, started to get more and more complex. We have ever-growing demands on products that need to be delivered faster and faster in a volatile market environment, and this pressures all product processes. And that comes to today, where breaks in tool chains, unreliable data, and rigid processes are no longer an option. So that's why PLM systems had to change, and PLM systems have evolved into PLM solutions. And a modern PLM solution is both a consistent storage and a reliable broker for all product-related data. That means it wants to guarantee reusability, consistency, and availability of the data it manages. It wants to provide information from process partners to engineers and to other development participants. And of course, it wants to deliver process outputs back to the process partners. So PLM learned to cover more and more processes, as well as to interface with the processes it does not cover or does not yet cover. The walls between process domains like ERP and MES have been teared down during this evolution from both sides. This means a modern PLM solution harmonizes the product, the process, and information technology. In the future, this new understanding of PLM is even more important because PLM solutions have to provide both data and context for next generation solutions, talking of AI agents and, for example, MBSE landscapes. This new understanding of what PLM is and how it needs to be harmonized with your very processes, regrettably, is not how PLM implementation projects typically are set up. Often PLM is seen as a data management tool and not as a process solution. That's what Philipp also just said. So additionally, the wish to be fast and to standardize supersedes the fact that the specialized processes of a company are what makes them uniquely successful, just like their products do. So if we do not honor what has made your company successful so far, introducing PLM will not be successful. It will lead to sunken costs instead of a return of invest. It would be like buying an electric bike, but never loading the battery. But even if you get to a good understanding of what PLM solutions can do for your engineering process, and even if your general idea to market process is is given, a successful realization of that vision is not easy. Companies trying to walk their path towards a good PLM solution often set up long-running, overloaded projects. That's typically because trying to implement a good PLM solution may seem overwhelming. There's a huge load of different data that has to be migrated and managed. There is a fragmented tool landscape that needs to be replaced or integrated. And there are people who have learned to work self-optimized, and now they have to learn to work process-optimized. Processes that grew over decades need to be challenged and refurbished. All of that while the world, the company, and the products are constantly changing. But there is a way to handle this complexity. There's a way to speed up the delivery of PLM solutions and to think your digital transformation as a journey. This journey could look like this. There are 4 stations. Station 1 is the process decoupling. We always start with processes when we start with PLM. That means we look at your processes, the defined ones as well as the lived ones, and we analyze them. What dependencies are there and what required process interfaces do we have to look at? This is based on your situation as well as established patterns known from several other projects. In station 2, we do the master data definition, which is an in-depth mapping of the product data along all those decoupled processes. We need an unambiguous definition of who is responsible for and who needs which data at any given step in this process, so that in station 3, we can define the potential for change based on your business goals and based on restrictions what must not be touched right now. We can scope digitalization steps. The results of the above steps, meaning step 1 and step 2, will guarantee that we are able to transform one process at a time without harming another. In station 4, finally, we will implement fast but small steps. That means we, as consultants, will help you to implement best practices, both for your domain and your company size, and you will help us to understand what needs to keep running, what made you successful in your past. And if it is a journey, we will not travel alone, and you will not travel alone. That means there will be many people to hop on, many decision makers, process owners, and users all have to join this journey. Basically, that means that the PLM solution project will always assure that the management goals for the transformation are clear, up to date, and that the management shows interest in the transformation that is going on, as well as that users are part of the solution definition and of the implementation to make sure that no real-world detail is unseen by the project. And we do not want to deliver anything or something after 2 or 3 years. We want to be fast and we want to be value-driven. That is why we recommend a hybrid approach to orchestrate this PLM journey. We have a classical tracking for transparency, which means we have one aligned goal, but many intermediate stopovers, like milestones. And we have an agile implementation method, which means we have a freedom in the project on how we reach each and every individual stopover. This is how modern PLM solutions can be realized fast, transparent, and despite the complexity of the task. But even if we achieve this modern PLM solution, there will always be more to accomplish. This journey will not be over so fast. A good PLM solution will always continue to improve and to grow, just as you as a company will. And even then, the PLM solution will never cover each and every aspect of your processes, and it does not even want to do so. So it has to understand, and the PLM solution has to understand that it is a key part of your digitalization transformation, but still only one part of this transformation. It has to be integrated, even if it is value-driven and future-proof, into your process landscape, into your digital process landscape. And that's why I will continue or give over to John to tell you more about this. Sorry.
So thank you, Mendel. Thank you, Philipp and Stefan. I think you've set a very important foundation of understanding, and thanks for your unique intro to Memoria by Antemia and the 20 years of PLM experience at ECS. Now, what we've seen is that engineering digitalization and PLM, which it often evolves around, are not just a tool, or a system you buy. It's deeply embedded into your engineering processes, and those processes are becoming more complex and more faster and more interconnected the more your product landscape grows, right? And the more products evolve. At the same time, many of these transformation efforts struggle, not because they're missing tools, but because of disconnected systems, fragmented data, and processes that don't fully align with each other. So I think so far, one of the key takeaways is the challenge is not PLM itself, it's everything around it. And that's where I'll build on from now. And I want to show you how you can create that connection layer across your engineering landscape and turn those challenges and the solutions into something scalable. So up until now, we've talked about the complexity of PLM and engineering processes, right? And what we typically see in reality is that these worlds are not truly connected. They exist in silos with a lot of manual or Excel handovers and inconsistent, non-aligned data, right? And this is exactly where we at SnapLogic has over the last 4 or 5 years have really gotten ourselves into to partner with companies to solve this kind of problems. So SnapLogic can act as the integration and automation layer between the PLM system in the center, the MB is model-based systems engineering, and your workflows and people. So instead of isolated tools, you get one working automated layer, which makes your engineers more effective, your business processes more effective, and ultimately your development faster. Now, this does not stop at PLM and NBSE, right? Once you establish that layer, you can extend it across the entire engineering ecosystem, right? Because if we zoom out, this becomes a lot bigger than just PLM. SnapLogic can act as the central integration layer across your entire engineering ecosystem. It doesn't have to be SnapLogic, but a tool like SnapLogic, but we obviously highly recommend SnapLogic. So you have your shop floor systems, right? You have your external data sources, APIs, vendor interchanges. You have your lake houses and warehouses and graphs. And you're obviously nowadays, and everybody's talking about your AI automation and agents around this golden triangle between PLM, MES, and ERP most larger companies are using in today's manufacturing world, right? So SnapLogic can unify all of this into one connected layer. And not only by moving data, but it's more about standardization and how systems and processes interact and how people use this interfacing layer. And this is really where it becomes powerful, right? Because once you have this foundation in place, you can go further and look into the future and how you can further improve processes with modern technology. Now, what is SnapLogic, right? I'll be real quick on this one, but we're a low-code, no-code integration platform that connects data. So data integration, moving large amounts of data and manipulating it. Application integration, meaning automating business processes, business workflows, and handoffs between systems. API management, building and publishing APIs to secure systems or provide data to other external systems in a scalable way. And of course, AI integration into one unified, user-friendly environment, right? And at the same time, this is really fully enterprise grade. You can run it on cloud, on hybrid, or fully on premise. And it doesn't only allow you to bridge between IT systems, but also bridge the OT and shop floor data gap, and also integrate upwards into AI and cloud systems of this world, right? So you're not only connecting a full stack from engineering to operations, but you're also providing a centralized platform with reusable workflows that is easy to use, and of course has significant cost benefits on multiple levels as well. So if we're talking what this can do for you and what the core capabilities are, is first of all, you get a unified set of capabilities. So it brings you all kinds of integration capabilities across data, app, APIs, and AIs in one platform. Secondly, it enables domain-driven execution, right? So it eliminates the IT bottlenecks from its ease of use. It brings your domain experts into building these interfaces and typically has a twice as fast integration speed versus our competition. You can unify your stack, so you don't need a different tool to integrate between each system layer, but you can do it all in one platform. And SnapLogic is by design bidirectional. That means systems can stay synchronized, not just connected. So instead of building point-to-point integrations, you can create a scalable integration layer across your business. Now, let's put this in a few concrete examples that I've seen in our customer base that we've been doing for the last couple of years and brings this closer to you. So first of all, PLM synchronization, right? So a classic CAD handoff. So your CAD data is automatically transferred into the PLM system, including the metadata and structures from the CAD related PLM, as you can see here. So the CAD world is Windchill from PTC and Creo, and then you have Teamcenter in the middle. And these are, let's say, fully integrated, right? Your model-based systems engineering, so integrating between 3D experience for systems engineering CAD, and then your requirements management in Polarion, and then Teamcenter, or your classic PLM to ERP integration. So material master handoffs, BOMs, changes are always synchronized between two main Teamcenter environments and one SAP system. And this creates a reusable integration layer, which takes away these manual processes. And then maybe looking into a more future-looking, or let's say more analytics and AI enabling use cases, bringing Windchill data into a world of Snowflake, where it then can get published into, for example, Microsoft Power BI for analytics, BOM deduplication, or even your AI projects of the future, right? The key point is these all follow the same principle. It's one integration layer connecting systems, processes, and data that Philipp and Mendel have described to you. Now, there's one more thing, as I like to say. It's a bit of an outlook into the future, and this is something I've been seeing across the industry more and more, right? So we've been talking about the PLM and MBSE world first, and how to, let's say, integrate that, redesign your systems. And then once you have really digitalized the PLM and MBSE and systems engineering world, you can think about integrating the CRM and sales ecoverse, your enterprise resource planning, your execution on the shop floor level, right? But then looking forward, what I've been seeing a lot lately is that the need to bring it all into a centralized semantic layer, like in graph databases, in central data warehouses, into streams, into vector data source for AI projects, and then using these data foundations for a wide range of projects throughout analytic and AI, really setting the general foundation, right? So I hope that was interesting. And this really brings me back to the question. what we started with, right? Faster chaos or smarter engineering. So what we've seen today is that technology is not alone, not the answer, right? You basically have three layers for this. You need three things working together, right? First, that deep understanding of your processes, responsibilities, and systems. That's Antemia, right? Then the strong expertise on PLM systems and PLM projects in the world. That's ECS. And a scalable integration automation layer, and that is us from SnapLogic. So we believe this combination of these capabilities allows you from fragmented tools and projects to a connected, scalable engineering landscape. So instead of accelerating your complexity, you create a real foundation for digitalization. And that's how you move from faster chaos to smarter engineering.
Thank you, Sean. Thank you, Mendel, and thank you, Philip. Before we jump into the Q&A, 2 more points. So where do we go from here? How can you stay in touch with us? How can we follow up on this together? So the first one is that what we offer you as a next step is a 1.5-hour assessment with all 3 of us, where we will look at your current situation and how we can shape tomorrow's opportunities for you, if there are any gaps, and how we can outline a concrete path forward. Following this webinar, there will be an email going out to you, including the contact information of all of our speakers. So we will be able to stay in touch if you're interested in this assessment. And the second one is more of an on-site touch point. We have a roundtable coming up with Antemia on June 9th in Graz in the Digital Lifecycle Lab. There's a Q&A, there's a QR code that you can scan here to learn more about this digital engineering roundtable. And you can also find the link under the tab Docs. Yeah, you will have the opportunity to sign up to this, and we would be very happy to see you in Graz if you're nearby or if you're interested in learning more about this. And with this being said, let's go into the Q&A part. So as mentioned before, feel free to keep dropping your questions in the Q&A tab. We already have some questions, so we would start with those, starting with the first one. So this says, we are facing opposition of users refusing to change the way they work or use new tools. How do we get them to be part of the change?
Maybe if it's okay, I start right here and then you guys can join in. And for me, there is one topic and it's called quick wins. So we need to, of course, we have to have our high level vision. We have to get that connected with our operational goals. But to get it to our employees, we need to find certain aspects where they see why this makes sense. And defining and looking for these quick wins, which is see right away that, okay, if we contribute to that change, it helps us or it helps the whole company. From my side, that's one of the key points.
Yes, I think that's a good point. And what I think of are 2 additional points. One is that always the vision has to be clear, and there has to be a real interest, especially from the management level, in this transformation, so that everybody in the company knows this is required because it will benefit our company. And second, of course, is to let them be part of the journey and to show a real, genuine interest in what they are doing today and help them to get an idea of what they can improve by themselves. So they should be part of the project, they should be part of each and every decision, at least to the point where they feel understood and that they know that people doing the project understand what changes this.
Thank you. There's another very topical question as well, important to raise. How do you see the role of AI in model-based engineering?
Sean, do you want or should I?
I can take what I'm seeing, right? So first of all, there's 2 layers to this. So one is the AI within the actual workflow, right? So it might be, the manual handoff or deduplication of documents, the reading in of the translating of documents to data, right? Especially around also mapping into, let's say, a unified structure. That's where I would say within the, let's say, the data handoff within the engineering. More, if you look to my last slide, like if we move to the top level above the semantic layer, there's many use cases here, right? Standardization of parts and supply chains, BOM deduplication, automating certain engineering handoffs, right? There's the, let's say, requirements, let's say a deduplication outreading, feedback from service, automatic passing over of supply chains, right? I think all of those really expensive problems that we've seen in the past around both ends of the manufacturing process can be solved in this ecoverse, at least to an extent, right? And that's where I see it more and more, rather than in the actual process. But Philipp, please give me your take on it.
Yeah, so from my point of view and from the engineering point of view, I think it's kind of an accelerator, I would call it. So it's very good at consistency checking, at finding anomalies and stuff like that. But this well-founded model-based foundation is still very important. Otherwise, these agents do not know where to start and where to end. So from my point of view, it doesn't take away all of it, but it helps getting faster and model generation, even in software, of course. It's more advanced right now, I would say. But having this model-based foundation definitely gives you all the possibility for what's to come in the future.
Yes, and I think right now we are just beginning to understand what AI will be able to do for us, because right now many people are experimenting with it. So I think it will be very beneficial for all engineering processes. But what we see right now is that AI has some dependencies. One is, of course, that the AI itself has to be mature to be used. But there are two other dependencies which require this digitalization process. AI will always need data, and this data has to be available. And the second one is an AI will always need context, because without context, the AI will only guess or hallucinate. So that means if you do not have a good digital foundation, it doesn't matter what AI could do for you, because it will not be able to do anything. So I think AI will be the future, but we have to be digital for this future.
We have a very interesting question here, and not easy to answer, but I think our collective intelligence might be able to. So Peter asks, I always found that the project sponsors underestimate the need for proper change management for the success of an endeavor, right? And instead of that, the IT department, which is deemed the furthest away from a process mindset, is given the ownership of these projects, right? And the question is, how can a use case-based thinking heavily supported by AI drive the success of projects? Basically, how can the importance of the aspects being increased? So I can only answer it on the integration level, right? But this is really what we've been trying to drive with SnapLogic for a while now. So the problem with this is the IT really often doesn't understand the overlying business process, or if they understand it, you have a handoff of kind of fusion teams or whatever you may call it that work together to build a project, right? Now, what SnapLogic's purpose is, or what we are trying to drive, is really enabling the let's say domain experts in the business with the tool, because it's pretty, let's say, for an integration tool, it's pretty easy to use, and you have a lot of AI helping you develop pipelines, right? And of course, with partners such as ECS to enable newer domains like yourselves that actually own the process rather than the IT below it, to build their own integrations and bring their process knowledge into the integration without the back and forth handoff between, let's say, lines of businesses, which slows projects down, brings in more stakeholder complexity, and makes it very difficult to build an overarching decision maker, let's say, matrix. Because what I've also seen is, your business matrix and the IT decision maker matrix, it goes like the leadership level is pretty high up. So you won't really get somebody who can say and put his foot down on things, so things become, let's say, round discussions rather than somebody, top-down leadership, which is sometimes really required, right? So I would say, bring yourself a platform in, enable your people, bring a partner in, have clearly defined leadership, and then implement the project in small sprints rather than trying to, give the entire domain ownership away.
Maybe from my side, besides the leadership, which is very important to have certain things like fixed, is what we do here in the Digital Lifecycle Lab. So we invite then teams with stakeholders from all domains, also the IT, but also the people who have to work with it later on. And we try to find common ground. So what do they need really defined? And I like the use case-based approach because this is our core. We need to define what use cases are relevant for the company, and what would be maybe an over-engineering for this use case. So what do they really need, and how could we reach that the easiest way? And if we sit together here, we can try it, we can build it up in our systems and replay it, and then we most of the time see that, okay, certain things are not as we thought before, and then find solutions and common ground to further, and that's what Sean already said, take those small steps and start implementing.
Thank you. I have one more question. So we have some more minutes. So if you have any other questions, feel free to drop them. This one says, we have a highly customized tool landscape tailored for our processes. How could it be possible to harmonize and decustomize that?
I think I'll hand that off to Mendel.
Yes. So highly customized environments are typical, and that's why we have to be very careful in addressing such topics. The problem is that we cannot change everything at once, right? We already said it during our discussions and also during some answers that we need to take small steps. And that's why it is so important that we have a clear data master definition and the process decoupling, so that we know what process depends on which other process and what tool can we touch and replace step by step, so that we can integrate data, migrate data, or if needs be, integrate different systems. So the way to decustomization typically should not be standardization. I know it sounds a little bit counterintuitive, but standardization typically leads to not optimal processes, but it should be an analysis what is required from the process, and then we know why do we have this customized product, and then we can work with patterns and with best in slot solutions, or with best practices for use cases to replace a customized product by a configured product. And the configured product typically is easy to handle and still keeps your business benefits.
Thank you, Mendel. I think we have time for one more question. And if there's anything else that comes to mind after the webinar, as mentioned, we will include the contact information so you will be able to reach out. The last question is, what should we not digitalize?
I can maybe tell a little bit what should not be digitalized or what should not be replaced by digitalization. The most important thing is communication. What we see in many of our projects is there comes a new tool, there comes a new technology, and suddenly people who has been very interactive for their projects and for their daily work they stop communicating and they stop exchanging informations. And that's not what digitalization wants to aim for. Okay, digitalization, of course, it wants to have digital data. It wants to guide you digitally through your processes, but also it is only a platform for communication. And you should not aim to digitalize all your communication or your people, right? They need communication for their processes. Elsewise, there's a very, very high risk of inconsistencies and of very late product stages where errors might be found or communication errors might be found.
Thank you, Mendel. And I think with this being said, thank you everyone for joining us today. We hope we covered all the questions you had in mind. You can reach out after the webinar. The contact information will be shared with you, as well as the opportunity to arrange a follow-up with us. And with this being said, have a nice day and thank you for joining again.
Thank you very much.
Bye. Thank you.
Bye.
Bye-bye.